Welcome to the Math Record. Today I'll be covering the ICTM Regional 2020 Division AA Algebra 1, which I'll be covering questions 7, 10, and 15. All the other questions I wouldn't be covering in this video, and if you have a question that you want me to answer, just put it in the comments below. I'll probably just answer it there. As usual, I'll cover all 20 on the, I'll go through all 20. Okay, so now let's go with number 7. So a lattice point is a point whose coordinates are both integers. Consider the region bounded by the x-axis, the y-axis, the line 6x plus y equals 30. Determine the number of lattice points that exist in the interior of the region. So we had to graph this, the y-axis, the x-axis, and our line. Since the coefficients are positive, it's something like this. Okay, so now we need to find our y-intercept and our x-intercept. So if x is equal to 0 in our equation, that means 5y equals 30. That means y equals 6. And if y is equal to 0 in our equation, that means 6x equals 30. That means x is equal to 5. So this is 5. Okay, so we got our x-intercept and y-intercepts. So since our last points is basically coordinates are both integers, that means x can only be from 1, 2, 3. Well, not really evenly spaced. Let's move it a little bit more. 1, 2, 3, or 4. So these are only points where there make last points in the boundary and interior of it. Okay, now we just need to find the y values because that's just on the x-axis, and we need to find it on the line. So when x is equal to 1, that's 6. 30 minus 6 is 24. That's 24 over 5. And if x is equal to 2, that's 12. 30 minus 12 is 18, and then 18 divided by 5. And then we have 6 times 3 is 18. 30 minus 18 is 12, so this is 12 over 5. And then 6 times 4 is 24. 30 minus 24 is 6 over 5. Now let's convert all these into decimals. So this is 4.8, this is 3.6, this is 2.4, and this is 1.2. Okay, so that basically tells us that the y value only goes to 4.8, this one goes to 3.6, this one goes to 2.4, and this one goes to 1.5. So our last points here are 1, 1, 1, 2, 1, 3, and 1, 4. And this one is 2, 1, 2, 2, and 2, 3. And then 3, 1, 3, 2, and then 4, 1. And those are our only ones. So count them 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So our answer for number 7 is 10. Okay, now number 10. A two-digit positive integer has the property that the square of the sum of its digit is equal to the integer itself. Determine the integers that meet this criteria. So let's say our two-digit is 10x plus y, where x is our tens digit and y is our units digit. And then they say the square of the sum of its digits, so x plus y, so the sum and then the square of it, is equal to the integer itself, so is equal to 10x plus y. So basically, from the statement, we could use a bit of logic, and we know that our integer is equal to x plus y squared. That means our integer has to be a perfect square. And they also said the integer is a two-digit, so it's a two-digit perfect square. So if we have 1 squared, that's 1, which doesn't work. 2 squared is 4, 3 squared is 9, and then 4 squared is our first double-digit perfect square, which is 16. And then 5 squared is next, which is 25. Then 6 squared is 36. 7 squared is 49. 8 squared is 64. And 9 squared is 81. So these are our only possible ones because 10 squared would be 100, which is triple digit. So now if we look at this, we need to satisfy this equation. So that basically tells us that 1 plus 6 is 7. 7 squared is 49, so that doesn't work. 2 plus 5 is 7. 7 squared is 49, doesn't work. 3 plus 6, 9, which is 81, doesn't work. This is 13 squared, which is 169, doesn't work. This is 10. 10 squared is 100, this doesn't work. So the only one works is this one. This is 8 plus 1, which is 9, which is 9 squared is 81. So this works. So our only two digit that works is 81. And that's our answer for number 10. Okay, so it's just like a trial and elimination question. Okay, number 15. Given x squared plus y squared equals 2xy plus 10,201 and 3x squared y minus 3xy squared equals 2020 minus 5y plus 5x, determine the smallest possible product xy. Okay, so I usually like to put all the variables on one side. So we have x squared plus y squared minus 2xy equals 1,201. And I recognize this equation. It's really common. It's actually just x plus y squared, and that's equal to 1,201. And then you could just use your calculator and then take the square root of 10,201, which you will get 101. Since it's x plus y squared, that means x plus y is equal to positive or negative. It's one or the other because it doesn't matter if it's squared. And now we can work on our second equation. So move all the variables on one side. So 3x squared y minus 3xy squared plus 5y minus 5x equals 2020. And now what I noticed that there's a 3 here, 5 here, and a 5 here. So we're probably going to use completing the square. So distribute out a 3x and a y, which would leave here factoring out an x, factoring out a y, plus. So I need an x minus y here, but this is a positive y and this is a negative x. While this one is a positive x and this is a negative y. So instead of distributing out a 5, you distribute out a negative 5. So this gets negative y and positive x. So positive x, negative y, and that equals to 2020. So then you could combine the squares basically. So 3xy minus 5 and then x minus y times x minus y equals 2020. And right here, we're looking for the smallest possible x times y. So that's what we're looking for. So we need to find this value. Well, we already found it. It's right here. So just plug it inside. So since we want the smallest possible, we want to use the negative version. So we have 3xy minus 5 times negative 101 equals 2020. And then you could just use your calculator to do the rest. So 2020 divided by negative 101, and then add a 5, and then divide by 3, which you get x times y is equal to negative 5. And that's your answer for number 15. And if you want to know all answers for all 20 questions, here they are. Well, thanks for watching, and if you have any questions, put them in the comments below.